Everybody, I'm Callum at Repair Wins, and I've got what should hopefully be a fairly fast video for you today. I've got this laptop charger. It's got my sticker on it, and the reason why it has my sticker on it is because it was one of 3 chargers given to a business customer who purchased 3 Lenovo laptops from me. I made a 2-part series repairing those machines maybe a month and a half ago. But anyway, I got a text the other day saying, "Callum, hope you're well. One of the laptops has stopped working. Could you have a look at it, please?" So he drops it in, I took a look, and it just turned out the charger had died. I can see there's a bit of damage here, which I'm fairly sure wasn't there when I gave it to him. I can't say either way, but all I did was I tested the laptop, gave him a new charger, and he's away. Anyway though, the charger I gave him was the charger for my own personal laptop, because my laptop uses one of these rectangular Lenovo style as well. I don't have any of these things spare, the Lenovo ones. But what I do have is about 100 of these HPs spare. Now, the vast majority of them are 65 watts, and the vast majority of HPs that use this old style charger need a 65 watt charger, which kind of makes me wonder why HP built a 45 watt version. But my plan is, given that I don't need this, to just snip the wire fairly close to the base, snip this fairly close to the base, strip them both back, solder them together, and then at the end of it, I'm hoping that I'll be able to use this HP charger combined with this thing, Frankenstein style, to charge my laptop. So I'm going to set the camera up overhead and let's just get started. If you don't quite know what I'm talking about, I'm going to use this thing, which is called a multimeter, to show you the voltage. So if I plug this HP charger in, this Lenovo charger in, I'm going to set that to volts DC. And all I need to do, it doesn't matter which probe goes where, is put that one here and this one there. And it's 141 millivolts. It's just jumping around all over the place. That's obviously not a correct reading. If I now plug in the HP charger and do exactly the same thing, set it back to volts DC, I'll put this on here and this on there, and you should see about 19. There you go, look, 19.9. So clearly the HP one's working okay, the Lenovo one isn't. Now, if you're wondering why I don't just take this apart and repair it, it's because you can't. They're ultrasonically welded closed, and the only way to get them open is to either coat them in petrol and let the weld fail, or to use a screwdriver and a hammer and just bash it and then hope the casing splits apart. But normally they have a seam down the middle. This one doesn't. The seam is kind of here, and it's just not worth it. I mean, this is only an experiment anyway, because I can buy one of these for £8 on eBay, but let's just try and make something work. I like these HP chargers actually, because they have a really sturdy bit of Velcro on them, whereas the Lenovo one is just puny and it's all falling to bits, and it's a bit scabby. But I'm going to cut the HP one fairly close to the stem, so there shouldn't be any voltage left in here, but, you know, let's just, I mean, there might be a small spark. I really don't think there's going to be. If I just cut it about here. Right, so there's no going back now, and if you're wondering what I'm going to do with the scrap wire, I can either solder this onto something else in the future, or I can just chuck it in the cable recycling bin. But what I'm going to do now is do the same to the Lenovo charger, so about here, again, fairly close to the stem, just cut. Before I forget, I'm just going to remove this rubbish bit of Velcro from the Lenovo charger. So that's gone, it can go in the bin. Then I'm going to get this quality bit of Velcro, and I'm going to put it around here. And a little trick for you to stop it from sliding down and irritating you, just put a zip tie on. So there we are, that physically can't slide down anymore. I left a bit more length on each end than needed because I'm expecting to need to do this 1 or 2 times, but I'm going to strip back a good distance from here. Pull this insulation off. I'll do the same on the charger end, although I need to be a bit more cautious, so let's just make sure I strip the same amount. And yeah, you can see there's 3 wires in here, because the HP chargers negotiate the charging current with a resistor. So I'm pretty much going to be bypassing that and crossing my fingers the charger still works okay. And far more than I need, by the way. I'm just going to get this piece of green heat shrink that's much thicker than it should be, put it on there. If I don't need it, I can cut it off with a razor. If I do need it, I'll be really glad it's there. Then I'm going to get these 2 pieces, and if they're thick enough, I'll put them over this piece. Yeah, there you go. I can slide that all the way down, and I'll do the same thing again. It's always better to have a bit more heat shrink than you need than think, oh gosh, I don't have enough and now I can't cover my wires. And for the Lenovo, the ground is on the outside, the 19 volts is on the inside, and you can split it apart roughly in the centre, look. Then when you split it apart, you just twist these together. And I've made this much longer than it needs to be because it's quite hard to get insulation around these things. So I'll do that, and I'm going to strip a bit off of here, just like this. Again, we're going to twist that around. I'm doing a bit of guesswork here, but I think the blue wire is the signal wire because it's really thin and a bit rubbish, whereas the white wire is fairly sturdy and flexible, and so is the black wire. Now, for 99.9% of devices, black is ground, and normally the positive would be red, but if the black's ground and that's the signal, then that only leaves that to be the positive. As for the Lenovo charger, I'm not certain, so I've put the multimeter in continuity mode, which means it'll beep when I touch the probes together, and that just means it's a complete circuit. So I expect that the white wire is going to be positive, and the one with nothing on it is going to be ground. So if I put this on here, which is the one with nothing on it, and I touch the outside of the casing, there you go, it beeps because that's ground. And you notice we get nothing on the inside. If we do it the other way around, there we are, look, beeping on the inside. I have my soldering station set to 370 degrees Celsius, and that is because I'm using lead-free solder. I'm then going to get this and this, I'll spin them both together. And I'm just going to take my chances and leave it floating on the desk. But now I'm going to flood a bunch of solder in really quickly, because I don't want the heat to travel down the wire and then shrink the heat shrink. So that is a very good solder joint actually. There you are, more than enough solder flooded through. I'll just switch the iron off, I'll give that a minute to cool down, then I'll be able to shift this heat shrink up, that heat shrink down, and we'll be able to shrink them into place. Hot air goes on. I have it at 270 degrees, the airflow is maximum. Just going to run it, I'm going to slide this into position, hold it roughly in place, and just start shrinking it down. Which is why I don't mind the solder being sort of a blob in the middle, because I use more solder than needed. I really make sure to sink it down there and sink it down properly. If I just shrink that and then quickly slide this along, we'll shrink this too. And that's all that needs to be done. Now this heat shrink is shrunk in place, and it's going to do just what it needs to do, which is stop these two wires from connecting, because we don't want this and this to short together, which is why we use the heat shrink. I've now switched the iron back on, and what we're going to do now is use a bit more heat shrink tubing. Going to see if I can get away with putting this fairly long piece on, because ideally we would cover the whole wire if possible. Maybe I'll just trim it down a little bit. There you go. Don't think I'm going to get away with it, but it's worth trying. And then I'll put this piece on the other side, which is cut down to about here. So now I can twist these two together, ideally as close to this piece as possible. Actually doesn't hurt to sort of bend this slightly just to get it to go where you need it to. Then once you've started the fold off, you can wrap it around, look, and then sort of pull it so it flattens out. To a point, obviously. Now this too can be soldered. Now I see this heat shrink here shrinking, to be honest, but I guess it's a gamble I'm going to have to take. Same as last time, 370 degrees. And I'll go as far left as I can. Oh, I think we've gotten away with that. I'm going to flood a tiny bit more on. Yeah, we got away with it. This end has shrunk down slightly, but I'm able to hold it just out of the way. And I'm going to have to hold this here, because I want to shrink the very back down. Obviously without burning my fingers. But you shrink the back, then it's going to hold itself in place. Ow. Which will then allow me to move the other piece up and over. Oh, might need to be fairly delicate here, because it has shrunk a bit already. There we go, I've managed to get it over, and then we can shrink the rest. Now, if someone who wants to make this really pretty could have done a better job, they could have made these wires a lot shorter, so we don't have so much slack in the middle. But that's why I've put a bunch of heat shrink over the other end. I wasn't going for pretty here, I want to go for functional. But again, I don't care if people know it's been repaired, because that's kind of my whole ethos. As predicted, I wasn't able to slide this piece of heat shrink here all the way over to the other end, because we have a lump in the middle. But like I said, that's why I've put these blue bits on. But I'm going to shrink this one down first, and then we'll move the blue one down, and then the other blue one, and we'll shrink those both into place, and then it should look okay. Gosh, unlike the other stuff, this stuff actually shrinks. Oh, even better, I can be really sneaky. This might be a bit of a squeeze actually, let's see. I want to be able to get this end over that end. That'd be good. Yes, I've done it. Now we can just shrink the rest of this home. I'll tell you what, it's going to be quite rewarding to use this laptop with this charger, provided this charger works, of course. If it doesn't work, then believe it or not, even with editing and stuff, or should I say, prior to editing, this has only taken me 20 minutes to do. So it's really not a lost cause, because remember, you need to take on personal projects like this, even if they don't make you money, because it allows you to hone your skills, and you got to do a couple of things for yourself every once in a while, otherwise you're going to get really fed up. I run an electronics repair business, and I run an electronics repair focused non-profit, but I still need to do the personal jobs for myself that are, quote, a waste of time and don't make any money, because they're the jobs that I actually enjoy doing. If every job you do has to be something to make you money, it's not a hobby anymore, it's a job. And that sort of takes the fun out of it. I'm going to put a zip tie here, a zip tie there. I'm going to cut this zip tie from earlier, and we're going to give this thing a test, and fingers crossed it works. First thing to do before plugging it into my laptop is to check this thing's outputting a voltage. So I'm going to plug it in. There you are, hear the little crackle. We're going to run the wires just sort of down to about here, that'll do. I'm going to grab the meter, put it on the outside, grab the other bit of the meter, put it on the inside, and this should read 19 volts on the screen. Thank God it does. If that had said minus 19 volts, I would have been pretty damn depressed, you know, because that would have meant I'd soldered the things the wrong way around. Don't worry about it jumping about, it's because I've not got a very good grip on the probes. But I'm going to turn this off, and let's just, you can see 98% down here, because I charged it at my sister's house earlier. We're going to plug it in, see if it goes bang. Right, so it's not gone bang, and it's made the noise, and it is charging. I'm actually quite pleased with that. That's like 15-20 minutes of work, if that. Now, obviously, I can buy one of these chargers at £8 on eBay. It's going to take me an hour and a half, maybe, to edit the video and make the thumbnail and stuff. So, earning £4 an hour, not great, but remember, like I said, this wasn't a money earner. But yeah, that's working fine. I'll just leave it and see if it charges the 2% to 100, because sometimes, when you do a mod like this, it will sustain the battery at its current voltage, but it won't actually charge it. And the reason for that, if you remember, is that the HP charger had a blue wire inside, and that wire has a resistor on the other end, and that resistor tells the charger, it tells the laptop what wattage the charger is. So 45 watts, 65 watts, 90 watts, and then there's a couple of others for HP. That resistor obviously isn't connected to anything, so it's 50-50 on whether the laptop actually takes a charge or not. It's failed, unfortunately. This is stuck at 95%. It's been at 95% for sort of 10 or 15 minutes. I watched an 8-minute YouTube video with the charger plugged in, and it's not gone up even slightly. I'd already recorded the outro to this video, and you'll have heard me mention throughout that it didn't work. But that says 97%. And I'm using the same charger, because I don't have any other chargers. You can see the HP logo right there. So it turns out that it is working. Maybe because it's a 45-watt charger, the battery only charges when the lid is closed. I mean, I didn't leave it closed for that long, and I have been using it for a while, but I mean, I'm happy with that. This janky little charger, it turns out, is actually charging the battery, so I think we can call this one a success, surprisingly. Just prior to recording this outro, I watched the laptop tick up from 97% to 98%, so yeah, I was happy with it working 50%, but to have it working 100%, that's even better. Hopefully you found the video useful and that you haven't just wasted 10 minutes of your time, because if you're watching these videos and you are repeatedly not getting any value out of them, I'm not doing my job. At the end of the day, as much as I'd love to have loads of subscribers and get paid to do this, there's no point me putting out videos that don't benefit people, because that's what I'm here to do. I want to share my repair knowledge with you and hope that you get something out of it. It can't just be an exercise in validation for myself. Not that it is, by the way, but I hope you know what I mean by that. But I do enjoy doing these silly little mods and, you know, kind of wasting time. But if it's not benefiting anybody, and if I'm spending 4 times longer doing every repair because I'm recording it, then, you know, neither of us should bother. But I guess you can show me that the video is useful to you by leaving a like, maybe even go down to the comments, and if you can see an area for improvement, then please tell me about it. You know, I want to grow the channel, I need to increase the subscriber numbers, I want to get the repair message to as many people as possible. The best way to do that is to get it to as many people as possible. How do you get it to as many people as possible? You make the videos engaging, you make them entertaining, and you make them useful to people, you know, and that is by far the most important one. It needs to be useful, then it needs to be educational, and then I suppose engaging wouldn't hurt, would it? Although you have these two and the third one follows. So yeah, feel free to go down to the comments, tell me what I can do better. I'm really eager to get any feedback at all. Get the repair message out to as many people as possible. More people keep their own money in their own back pockets. We could all do with having a bit more cash these days. If you'd like to see where the channel goes and what stuff I put out next, then the best way to do that is to hit subscribe. You can change your mind if you don't want to, although it's completely free, so you're not going to lose anything by doing that. I believe next time I'm putting out a video about microwave. Sadly it wasn't repaired, I do an autopsy on it, but it should only be a 10-15 minute thing, maybe a bit entertaining. Maybe you want to know how that little box that sits in your kitchen that cooks your food actually works. You might want to stick around and watch that. But until next time, I will see you later, take care for now, and goodbye.